So for the first part, we're just going to multiply the width by the depth by the height for a normal volume. It just happens to be an algebraic one, that's all. So should we do the easy ones first? 2x plus 5 multiplied by 3 minus x, just a standard FOIL, isn't it? So firsts, outsides, insides, lasts. I think that's going to give me 6x minus 2x squared plus 15 minus 5x. I can simplify that a little bit, can't I? Because I've got 6x, I've got a minus 5x, so add those two together, I'm going to get x minus 2x squared plus 15. Now I need to multiply by the height, so the area of the base, this is a sort of prism, isn't it? X minus 2x squared plus 15 times by x plus 1. And what I'm going to do here is I'm going to multiply x by everything in the first bracket and then 1 by everything in the first bracket. I think that's probably the quickest way of doing it. So x squared minus 2x cubed plus 15x plus x minus 2x squared plus 15. Tidy that up a little bit. So I've got minus 2x cubed. I've got x squared take away 2x squared is minus x squared. I've got 15x plus x is 16x. I've got 15. And I'll have a quick look at what they wanted me to get, and I'm happy because it's exactly the same. So I'm going to write as required. Okay. So that's pretty good. So we found the volume of the box, and now they're asking us on the next part of the question to find the maximum value of x that gives the biggest volume. Now, as soon as you see the word maximum, you've got to think of the word differentiating. Okay, the calculus, differentiating. So what we're going to do is we're going to differentiate this expression. Okay, and the way you're going to know that is you're going to see that if you see the word maximum or minimum, you know this is a cue for differentiation. Okay, which we study in year 11 in the before half time. Right, so we've got this minus 2x cubed minus x squared. So you could even do this part of the question, even if you couldn't do the first part, you can still do the second part of this question. To differentiate, so 3 times by minus 2 is minus 6x squared, minus 2x plus 16 equals 0. That's how to differentiate and find a maximum or a minimum. Now I don't like having negative x squared, so I'm going to take everything over to the right hand side. Yeah, putting equal to 0 is the way to find a maximum or a minimum. If you're worried you haven't done that, don't worry, because we will be doing that in the first half of the winter term in year 11. Okay, so 6x squared plus 2x minus 16. Everyone's an even number, so I can halve everything, can't I? Make it a little bit easier. 0 equals 3x squared plus x minus 8, and I've given a massive clue in the question. It says that it's give your answer to 3 sig figs, so I know that there's no nice answer to this. There's no whole number integer answers, so I'm going to use my calculator. So if you press Shift and A, you get this, and press number 2 for polynomial, and so we've got x squared, so it's degree 2, and you type in the question. Okay, don't get the signs wrong, and it will conveniently tell you the answer for the first part. 1.47, x equals 1.47 is a solution to this quadratic equation, 3 sig figs. Now, there would be another solution, of course, because quadratic equations usually have 2 solutions, don't they? If I finally look at the next one, I'll see it's negative, so that can't be the answer. I can't have a negative length, so I'm going to have to stick with 1.47. And that's it, that's the answer. That's the, if x was 1.47, that'll give you the maximum, the biggest volume of that shape. Okay, it's a bit of a war and peace epic there to read, so why don't you pause and have a good read through. And if you're concerned about this dy dx, don't be. As I say, we will be doing that very, very soon. And the first part of the answer, yep. And the second part of the answer, of course this is an 8-mark question, so it's very, very valuable. And there we have it.